This is an example of one of the problems on the worksheet we have in class. You can either organize the information in a Venn diagram or in a chart. I'll show you both ways. So first, a Venn diagram. Since some people have both a dog and a cat, we know these are overlapping circles. And we can see that 39% have a dog, so I write 39 here. And 34 have a cat. And 60% have a dog or a cat. That means out here 40% of people don't have either. And because 39 and 34 add up to more than 60, that means there has to be some overlap. And so if I take 60% away from 73, I end up with 13% of people have both a dog and a cat. And then that's going to leave me 39 minus 13 is 23 have just a dog, and 34 minus 13 is 21% have just a cat. And now you can answer all sorts of problems, like what's the probability that somebody has both a dog and a cat? 13%. Or what's the probability a person who has a cat does not own a dog? That's 21%. You could take the same information and answer those questions in a chart by making your chart as dog, no dog, cat, no cat. And what happens is you fill the numbers in from the problem. 39% have a dog, 34% have a cat. We know it has to add up to 100%. This is kind of a tricky chart problem because you would have to be able to take this 60% right here. Yeah, 60% right here. You'd have to take the 60% and either know that that represents these three boxes together, or use it to get that 40% have neither a dog nor a cat. And once you have the original information filled in, everything has to add up to 100%. So this would have to be 66, and this would have to be 61, and 61 minus 40, well, let's go 66 minus 40. So we end up with 21, and then 34 minus 21 is 13, and 13 plus 26 is 39. And so you could either do a Venn diagram or a chart on every single problem, whichever you make sense to you. After you get them set up, you have to answer probability questions. These will be on a worksheet at the beginning of class. Just some background information. This symbol, n factorial, means you're going to multiply a number. Like let's say you had 6 factorial. That would be equal to 6 times 5 times 4 times 3 times 2 times 1. On your graphing calculator, you're going to type in 6 and then math, and then arrow over to PRB and arrow down until you find the exclamation symbol for factorial. And 6 factorial is going to be equal to 720. We're going to use factorials as part of the equations for this chapter. Oh, and this is just a definition. You'd think that 0 factorial would be 0, but it's defined as being equal to 1, and we can talk about that later. So an example of the multiplication principle will be state license plates, not Idaho, of course, because we all have our 7Bs and 9Bs, but for a lot of states, they might have a license plate look like this, where the license plate consists of 3 letters followed by 3 numbers. Now, if there were no restrictions, like, for example, if your license plate could be AA111, if there could be more than one of the same letter or number, then using the multiplication principle, the number of permutations of possible license plates would be 26 times 26 times 26, because there's 26 letters, times 10 times 10 times 10, because there's 10 numbers, obviously, 0 to 9. And so the number of possible license plates would be 17,576,000. Now take that same multiplication principle to find the number of possible license plates, but imagine that you couldn't repeat any of the numbers. So for example, you couldn't have AA, you might have to have AB, M followed by 3, 2, 5. With no repeats, there's 26 options for the first letter, 25 options for the second letter, 24 options for the third letter. There's 10 options for the first number, and then we only have 9 numbers left, and then we only have 8 numbers left. So we multiply to find the number of possible combinations, but on each problem, you have to pay attention to whether or not there can or cannot be repeats. In this case, the number of possible license plates would be 11,232,000. The questions to ask are, what is the process, does the order matter, and how many ways can the different things happen? So let's say you had the word butterfly. If you wanted to know how many different ways you could order the letters in the word butterfly, you have to notice that there's 2 T's. And since T's are the same wherever you put them, it wouldn't matter if it was the first T or the second T. So you would take the 9 different letters of butterfly, 9 factorial, and divide out the 2 options for T, 2 factorial, and you would end up with 181,440 different ways to arrange those letters. Let me give a more concrete example of that, because those are fairly big numbers. Okay, smaller numbers, concrete example. If you took SAT, 3 different letters, and looked at all the ways you could rearrange them, there's 3 possibilities for the first, 2 possibilities for the second, 1 possibility for the last, so the number of permutations is 6. But if I then took laugh out loud, now if you think about it, laugh out loud doesn't really have a fancy L and a regular L, it just has 2 L's. So it's not like the SAT question. If I rearrange the fancy L and the regular L and make them look the same each time, I end up with these 2 being the same combination, these 2 being the same combination, and these 2 being the same combination. So the 3 factorial for the number of combinations has to get divided by 2 factorial for the number of repeats, because the L repeats twice, and 3 factorial over 2 factorial is 6 over 2, which means there's only 3 combinations. So you have to think about not just how many different permutations there are, but if there are repeats, dividing those out so you get the right number of possibilities at the end. So then we'll have 2 formulas we're going to use in this chapter. One is for permutations, where the order matters. 7 parts in a play, 16 people try out. If you were going to do this problem, the order would matter, because it would matter if you got the lead role or the supporting role or just whichever other role there was. So in doing this problem, you would find it out as 16 and 7 here. And you can actually type this on your calculator and not use the formula by finding the NPR button in the Math PRB menu in your graphing calculator. And if you use the graphing calculator to get the answer, you're going to type in 16 and then the NPR button and then 7. And that will give you a really huge number. If you take a look over here, I've done an example of how to do 6 choose 4. So I have 6 factorial on top. So this number right here goes on top. And then I take 6 minus 4 to get the 2 factorial on the bottom. And before you start multiplying, cancel out the stuff that cancels. And for this example, you end up with 360. Now for this other answer, it's huge, 57,000 possibilities. Think of all that headache for the drama teacher trying to figure out who to put in which spot in the play. The other formula you'll have to know is a formula for combinations, unordered, order does not matter. An example of this would be like if, let's say, 25% of people had type AB blood, which I'm completely making up, I don't know the percent. And I had 5 people walk into the room, and I wanted to know what's the probability that 2 of them have type AB blood. Well, it wouldn't matter if the first 2 did, so did have type AB, didn't, or maybe the first one and the third one, and actually you could keep writing these all out, but if you wrote out all the possibilities, it could be that none of the first 3 people did, but the last 2 did. And what the combination button gives you is if you take out, you don't have to worry about repeats, you have to worry about there's 2 Ds and there's 3 Ns. And so this would be written as 5, choose 2, like 2 out of the 5 people. And if you type it into the calculator, it's on the Math PRB menu. And if you do it by hand, then it's 5 factorial divided by 2 factorial times, and now you're going to take these 2 numbers and subtract them, 5 minus 2 factorial, which is 3 factorial. And working them out by hand, it's 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 3 times 2 times 1. And so what happens is you can cancel the 2 2s with the 4 and the 3 with the 3, and you end up with 10, which I couldn't actually fit in, but if I'd taken this list and wrote it all out nicely, which you might want to try, then there's 10 different ways you can have 2 people with the type A blood and 3 people without the type A blood. And the way I remember combinations and permutations is if the answer is going to be really big, it's a permutation, and if the answer is going to be a lot smaller, it's a combination. Here's your homework. It's kind of a short section, so we'll have plenty of time in class to get it finished.